I'm going to start our notes for Chapter 10 at the end of Chapter 10, where it draws some pictures of the classes they're talking about at the beginning of the chapter. This chapter covers unified modeling language so briefly that I want to spend a little more time on it because I think it's helpful as a planning tool to make sure that the architecture of your programs makes sense and is elegant. Much like using JavaDoc to just get yourself thinking about what methods are supposed to do, UML can help you understand what the relationships are between objects and decide what each kind of object should have in it. In Chapter 11, we're going to start writing our own objects, so this will be a nice warm-up for that. Right now, I'm just going to point out what the different areas of these are and draw some arrows and talk about what these things are. So each one of these boxes represents a class, and so some of the classes that we've been using so far are scanner and random and string are all classes that we've used, and I'll draw a picture of those shortly so that you can see how that would transfer to this kind of thing. In a unified modeling language diagram, they always look like this. The class name is here, always. The properties are listed at the top, so these are called properties. They're also called attributes. You also see them called instance variables. And we'll see more about why they're called instance variables later. Okay, so now that I'm in this zone, let's talk a little bit about what you might find in here. It's a little bit backwards from how you would write it in Java, and it's more or less like various other languages. No matter what language you're using, could be Java, could be something else, the UML syntax is always the same. It's always like this. This plus means public. This is the variable name, this X. And then this part is the type of the variable. This is the format that it's used for everything. So over here, if I were in here, this would be a public int x, and this would be public int y. And we'll talk a little bit more about why public, and I've never had to put a public before a variable name before, and other issues like that shortly when we look at the code. In the method area, this also means this is also the modifier for public. If it were not public, say private, then there would be a minus here. So these are all public because they can be accessed by anybody. When we start writing classes, it's very rare that we're going to have pluses in the attribute area. Most often we're going to make these private so nobody can just reach in and change stuff. And the only way you'll be able to get at them is by calling methods on those items, and the methods will be public. But for now, just so you know, this is the modifier. It means public. And this is the method name. This is the parameter list, which I'm sure does not surprise you. Let's pick this one since it does have parameters. Each parameter is listed with the name first. Name followed by type. And then if there is a return value of the method, it's listed here. So there's a colon, and this is the return value. So I thought it might be helpful to take one of these diagrams and to show you what the power just went out in school here to show you what the method would be like if I started typing the methods and the classes that are associated with this. So let me try the point first. This should not be a huge surprise since the chapter covers this in detail. Okay. For the point class, I'm in class point, and actually I probably will say public class point. We probably won't get too much into the public modifiers for the classes in this particular course, but just so you know. Now here's something very different from what we had before. So I'm going to say public int x and public int y. And the first thing you notice is I am not inside a method when I'm declaring these variables. They're right inside the class. And so they are, they're sometimes called class variables, sometimes called instance variables, properties, attributes, various ways of talking about these items. These are alive the whole time an instance of the class is alive. So talking about variable scope, if you declare a variable in main and it's good for all of main, if you declare it inside an if statement, it's only good inside that if statement. These, because they're declared just inside the class bracket, they're good until the end of the class, as long as the class is alive and running. And we'll talk about how we know if it's alive in a little bit. Here's the methods, just going straight from that from the UML diagram. Public point, this is a special method that we'll see more of next week. So this would, but this is just a strict translation right now. I'm not really talking about what it is yet. Makes two parameters, and we'll just put in an empty method body for now. Now here's my other one, which is a public string. This is the return type, which is listed at the end in the UML. ToString, doesn't take any parameters, and then we don't know what it does yet. We can't see what it does from the UML diagram. And then down here I'll end my class. So this is how I would take a UML diagram and translate it to Java. And we'll see some more classes that we're more familiar with in the next upcoming videos.